Good morning, class. Welcome to the second chapter of our probability and statistics class. We're going to discuss normal distribution. By the way, I am your instructor, Elaine Liao. So, for the first lesson, we're going to understand the normal curve distribution. And the objectives are understand the concept of the normal curve distribution. Second, state and illustrate the properties of a normal curve distributions. Third, sketch the graph of a normal curve distribution. And lastly, recognize the importance of the normal curve in statistical inference. So, in the previous chapter, we discussed discrete probability distribution. So, in this chapter, we will discuss continuous probability distribution that serves as a model in the inferential statistics. So, what is a normal probability distribution or normal curve? It is a continuous probability distribution that is frequently used as a mathematical model in inferential statistics. So let's have an example. A frequency distribution table of the scores in mathematics test is shown below. A frequency distribution table of the scores in a mathematics test is shown below. So we have scores of 21 that has a frequency of 2, scores of 2 that has a frequency of 5, 19 with a frequency of 7, 18 with a frequency of 11, 17 with 6, 16 with 3, and 15 with 1. Overall, we have 35 frequencies. So, we're going to construct a frequency polygon. So, how do we do that? So, let's create x and y axis where x will be your scores, will be indicated your scores, and y in the y axis is your frequency. So for the first one, we have the score of 21 that has a frequency of 2. So we're going to locate it in our graph. So here, okay, and then 20 with the frequency of a 5. So here, 19 with a frequency of 7, 18 with a frequency of 11. So here, 17 with a frequency of 6, and lastly, 17 and then 16 with a frequency of 3 and 15 with a frequency of 1. So we're going to connect the dots. So there, if you can see in this frequency polygon, we can say that 18 that the score of 18 got the highest frequency while the score of 15 got the lowest frequency. The standard normal curve is a normal probability distribution that has a mean or mu is equal to 0 and standard deviation of sigma that is equal to 1. Equation, this is the equation that describes a normal curve. So where y is the height of your curve, particular values of x, and your x is any score in the distribution or this is your random variable. The sigma, this is the standard deviation of a population. Your mu is the mean of the population. And your pi, this is a constant value, 3.1416 and so on. Your e, that's which is also a constant value that has 2.71 and 83. One important thing that we need to know in a normal probability distribution is the Z-table. Z-table is the table of areas under the normal curve. It is a measure of a relative standings. So, what are the steps in finding the areas under the normal curve given a Z value? So, first, express the given Z value into a three-digit form. Second, use the Z table. Find the first two digits on the left column. Third, match the third digit with appropriate column on the right. Fourth, read the area or probability at the intersection of the row and the column. And this will be your required area. So say table provide the proportion of the area or probability or percentage between any two specific values under the curve regions can be described in terms of area. So let's have an example to understand this better. This is the state table that will help you answering the following questions.
So first example, that is to find the area that correspond to say equals to 1. So finding the area that correspond to 1 is the same as finding the area between z equals to 0 and z equals to 1. So as we remember, our first step is to make it as a three-digit form. That is z is equal to 1.00. So in the table, find the row z is equal to 1. And here it is. Okay, so in the column, we're going to find the heading 0.00. So here it is. So read the area or probability at the intersection of row 1.0 and the column 0.0. So this will be the required area. So therefore, the required area is 0.3413. Okay, for our example number 2, that is to find the area that correspond to negative 2.58. So in the same table, the area that correspond to z is equal to 2.25 is the same as the area that correspond to z is equal to negative 2.58. So in the graph, so it is just in the graph of this region, negative 2.58 is on the left side of mean. Remember, normal distribution is symmetrical. Okay, so here, for example, number 2, same process. We're going to express the z into a three-digit form. So that will be, so example number 2, z is equal to 2.58. Okay, so in our table, find the row z is equal to 2. So 2.5. So where it is here. Okay, and in our column, let's find 0.08. So here. And then read the area or probability at the intersection of the row 2.5 and the column 0.8. Okay, there. And here. So therefore, the required area is 0.4951. So that's how you will find the area that corresponds to your z value.
So this will be the graph of our standard normal distribution. The normal curve for a population distribution is specifically determined by its mean equal to 0 and its standard deviation equal to 1. The horizontal base contains the z-score values associated with areas under the normal curve, which we already find earlier. So here, as you can see, we have the inflection point. So your inflection point is where the curve changes the direction of its bend and goes from bending upward to bending downward or vice versa. So here. And again, this is your mean and this is your standard deviations. And this will be your z scores or z score values. In our previous lesson, which is understanding the concept of a normal curve, we learned the basic concepts about normal distribution and its importance in statistical inference. We further learned its property and calculated probabilities using the normal curve table. So in our lesson, we're going to understand the z-scores. And our objectives are first, relate a random variable distribution to a normal variable distribution. Second, understand the concept of the z-scores. Third, convert a random variable to a standard normal variable and vice versa. Lastly, solve problems involving random and normal variables. We discussed the z-score briefly in the previous lesson. It is stated to be a measure of relative standing. These scores represent distance from the center measured in the standard deviation units. There are 6 z-scores at the baseline of the normal curve, 3 z-scores to the left of the mean, and 3 z-scores to the right of the mean, which you can also see in our z table. So the z-score or the areas under the normal curve are given in terms of z-value or scores. Either the z-scores locate x within a sample or within a population. So what is a population data? It is the entire pool from which a statistical same is drawn. It may refer to an entire group of people, objects, events, or measurement, while your sample data is a set of individuals or objects collected or selected from a statistical population by a defined procedure. So your z-score measures distance of raw scores from the mean. Here's the formula in calculating your z-scores for population and sample data. So here is for the population data, which is x minus your mu over your standard deviation, while for the z-score for sample data, that is x minus sample mean over your sample standard deviation. So to understand this better, we're going to discuss 3 examples. And for additional information, you may question what is the importance of the say scores. So raw scores may be composed of large values that will be 1 until 100, but larger values cannot be accommodated at the baseline of the normal curve. Remember, we have 6 scores at the baseline of a normal curve. That is 3 say scores to the left of the mean or below your mean, and 3 z scores to the right of your mean or to above your mean. So they have to be transformed into scores for convenience without sacrificing meaning associated with the raw scores.
Number 1, given the mean, mu is equal to 50, and the standard deviation of sigma equals to 4 of a population of reading scores. Find the z-value that correspond to a score of x is equal to 58. Your x, remember, that is your random variable. So let's first identify the givens. So for number 1, the givens are, we have mu, which is your mean, that is 50, and your standard deviation of 4, that tells you how spread the data is, and your random variable of 58. So remember the formula that we've talked earlier. So we're going to use z is equal to x minus mu over your standard deviation. So your solution will be, so z is equal to 58 minus 50 over 4. So 58 minus 50, that is 8 over 4. And the answer would be 2. So therefore, your conclusion will be the z value that corresponds to the raw score 58. is 2 in a population distribution. Sorry, population distribution. So let's draw this graphically so you can better understand. Yeah, there. So what's your mean? That is 50. What's your standard deviation? That's 4. So 54, 58, then 62. So this will be your 1, 2, 3, and 0. On your left side of your mean, that is negative 46, negative 46, negative 42, and negative 30. That is your negative 1, negative 2, and then negative 3. So this will be your conclusion. Okay, let's draw the normal curve. I'm sorry, please bear with my drawing. Okay, so therefore we conclude that based on the diagram, we see that a score of x equals to 55 correspond to say equals to 2, right? So which is above our mean. So where's our mean? Here. And this is our t. Okay, so we can say that with respect to the mean, the score of 58, the score of 58 is above average. Okay, and please remember, because a is equals to 0, this one, it is the center of your distribution. The negative say values simply indicate that these values are found on the left side of the center or your mean, remember. So this is your right side and this is your left side. I want you to try question number 2 because the operation of question number 2 is the same as your operation in number 1. For now, let's proceed to example number 3. Okay. So for example number 3, we have the given. So given your random variable that is equal to 20, your sample mean that is equal to 26, and your sample that is equals to 4. So the formula that we're going to use, which we discussed earlier, that will be z is equal to x minus your sample mean over your sample. Okay, so the solution will be z is equal to 20 minus 26 over 4. So 20 minus 26, that is negative 6. And negative 6 over 4, that is equal to negative 3 over 2. Or in decimal, that's negative 1.5. Okay? So therefore, our conclusion, the corresponding z-score is negative 1.5 to the left of the mean. Okay, remember you can, to understand this better, you can practice drawing this into a normal curve.
We have learned that the area under the curve is 1, so we can make the correspondence between area and probability. We have also learned how to use the Z table so that we can identify areas of regions under the normal curve. When we speak of a region under the curve, we are in fact interested in the area of that region. So in our lesson number 3, we will going to identify regions of areas under the normal curve. Our objectives will be: first, identify the regions of the area under the normal curve. Second is to express the areas under the normal curve as probabilities or percentages. And lastly, determine the areas under the normal curve given z value. We're going to discuss this further using the following example. Example in finding the area of a region and finding the area that correspond to each of the following z values.
In identifying the regions under the normal curve, we see that using the say table, we can determine specific regions under the normal curve. So for example, this is our normal distribution, and this is your mean. 50% of the region under the curve is below the mean, and 50% is above the mean. Specific regions can be determined in terms of their usefulness in a situation. Since the say table provides the proportion of the area or probability or percentage within any two specific values under the curve, regions under the curve can be described in terms of area. Okay, so for example, this is your 0. The area of a region between z is equal to 0 and z is equal to 1. Okay, so this is your 1. So sorry about my drawing. So this is your 1. So between 0 and 1, this is 0.3413. And then between 0 to 2, that will give us an area of 0.4772, right? Okay, we can do operation with the areas to identify more regions under the curve. So to find the area of a region between z is equal to 1 and 2, okay, so 0, your 1, and your 2, you're going to find this out, okay, negative 1, negative 2. We subtract 0.4772, which is the value of the area from 0, z is equal to 0, and z is equal to 2, minus 0.3413. That will give us an answer of 0.1359. So, sorry, 0.135 now, which is also equal to 13%, 13.59%. So if we look into this chart, you can see that from 0 to 1, it will give us an area of 34%, which is also equal to 34.30%. From 1 to 2, that will give us a 13.59%. And from 3, maybe 4, that is will give us 0.15%. So if we're going to add negative 1 to, if we're going to find the area from z is equal to negative 1 to z is equal to 1, that will give us a 68%. Of negative 2 to positive 2, that will give us 95%. And then from negative 3 to positive 3, that will give us 99.7%. Similarity, the area of a region between z is equal to 0 and z is equal to 3 is given in the say table to be 0.987. So please bear with my drawing. So 0.4987. So this is the area of a region between 0, z is equal to 0, and z is equal to 3. Okay, so the area of a region between z is equal to 2 and z is equal to 3 is given by subtracting 0.49 minus 0.4772. Remember, this is the area of a region from z is equal to 0 and z is equal to 2. So this one, z is equal to 0 and z is equal to, I'm sorry, to 3. To 3. So that will give you an answer of 0.215. So therefore, the area of the region between z is equal to 2 and z is equal to 3 is 0.215. Or we can say that is or 2.21.5%, which we can also see here. Okay, and so on and so forth. So um, like what I've explained earlier, so this will be the proportion of areas under the normal curve. Let's find the area that correspond to each of the following z value. Example number 1, we have z is equal to 0.3. So in this standard normal distribution graph, we're going to locate where is the 0.3. So it is located somewhere here. Going to draw a line. So let's say this is your 0.3. Okay, and this shaded part, we're going to find this area. And how are we going to find the area? We're going to look up on the say table. So first step, we're going to make this into 3-digit form. So we have 0.3, and in the column, we're going to find 0.00. Your value, the area value of at the intersection of row 0.3 and column 0.00 is 0.1179 or 11.79%. So meaning from your mean to 0.03, the area will be 0.1179 or 11.79.
You may try example number 2, but for now, let's answer example number 3, which is say is equal to negative 1.5. Okay, remember, when say is negative, we can simply ignore the negative sign and proceed as before. The negative signs inform us that the region we are interested in found on the left side of the mean, wherein areas are positive value. So, first step is we're going to make this into a 3-digit form. That is equal to z is equal to 1.15. And then, let's try to locate this in our graph. So, negative 1.15. So, this is located somewhere here. Okay, and then let's shade this region. Okay, so for our step 2, we're going to find the first 2 digit in row 1.1. So, here it is. Hold on, I can find my pencil. So here. 1.1. And then we're going to locate the third digit in the column 0.05. So here. Then we take the area value at the intersection of row 1.1 and column 0.05. So here. And then here. So therefore, this area is 0.3749 or 37.49%. We have learned that a standard normal distribution is a normal distribution with mu that is equal to 0 and standard deviation that is equal to 1. We have also learned that a random variable with a standard normal distribution denoted by x is called a standard normal random variable. Further, we have also seen that all probabilities associated with the standard normal random variables can be shown as areas under the standard normal curve. Now, let us learn how to use probability notation in equating desired probability to an area. So, in our lesson 4, we're going to determine probabilities. And our objectives are first, find areas between paired say scores. Second, find probabilities from the standard normal random variable say. And lastly, express areas under the normal curve using probability notation. Mathematical notations are convenient forms of a length expression. So in our example, in our daily lives, where instead of texting too long, we do shortcut text like Jejemon text or abbreviation messages. So here, it denotes that the probability that the say score is between A and B. Here denotes that the probability that say score is greater than A. And lastly, this one denotes that the probability that say score is less than A. And how are we going to read this? This is probability of Z that is less than A and greater than B. This one, probability of Z that is greater than A. And lastly, probability of Z that is less than A, where A and B are Z score values. So let's have an example. So denote the area between Z is equal to 1 and Z is equal to 2. Let's denote the area between Z is equal to 1 and Z is equal to 2. We use the notation P wherein Z is less than 1 but greater than 2. That is equal to 0.1359, which we can also read this one as the probability that the Z score falls between Z is equal to 1 and Z is equal to 2 is 0.1359. These are the steps in determining the areas under the normal curve. That is, first, draw a normal curve. Second, locate the given Z value or values at the baseline. Third, draw a vertical line through these values. Fourth, shade the required region. Fifth, find the areas in the Z value. And lastly, examine the graph and use probability notation to form an equation. So we have following cases or examples that will make us better understand. This chart will be your guide on what operation that you're going to use in the following cases.
Proceed with case number 1. So it says that the areas required as depicted by the shaded region under the curve are greater than Z, at least Z, more than Z, to the right of the Z, and above Z. Example number 1, we're going to find the proportion of the area above Z is equal to -1. So it will fall on this operation because proportion of the area above. So here, and our sign is negative, which means the probability of Z is greater than negative A value. Okay. So first step, we're going to draw the normal curve. So this is your mean, and this is your say value. Okay. This will be the shaded region. Okay. So we're going to consult the Z table to find the value of our Z score, that is -1. So Z -1 is equal to 0.3413. And if we remember, the operation that we're going to use is to add 0.5. Why 0.5? Because remember, our standard deviation, we have 50% below the mean, below your mean, and 50% above your mean. So the required area is equal to 0.3413 plus 0.5. That will give us an answer of 0.8413. So in probability notification, it is the probability of Z that is greater than -1 is equal to 0.8413. Therefore, the proportion of the area above is 0.8413, which is also equal to 84.13%. So 0.8413 or 84.13%. Example number 2 in our case number 1. So find the area greater than Z is equal to 1. So if we look into this chart, it says greater than, and the value of our Z is positive, which means we're going to subtract the area correspond to the given from 0.05. So this will be our operation. So to answer that, let's first draw the normal curve. Okay, so this is your normal curve. And we're going to locate the Z value. So your Z value is equal to 1. And it says um, area that is greater than Z is equal to 1, which means we're going to find this area. This is your shaded region. And to find that, we're going to find the Z value using our Z table. We're going to find the area using the Z table. And Z is equal to 1 corresponds to 0.3413. Therefore, the required area is equal to 0.5 minus 0.3413. That is equal to 0.1587. So in probability notification, it's the probability of Z greater than 1 is equal to 0.1587 or 15.87%. Therefore, the proportion of the area greater than is 0.1587 or 15.87%. So this shaded region means this is 15.87%. For our case number 2, it says that the area requires is less than Z, at most Z, no more than Z, not greater than Z, and to the left of Z. So for example, number 1, we're going to find the area to the left of the Z. Going back to our chart, so to the left of our Z, wherein we also have the negative sign because of negative 1.5. So the operation that we're going to use is to subtract the area correspond to the given from 0.5. So step 1, we're going to draw the normal curve. Okay. So this is your normal curve. And we're going to locate the Z value, which is on the left side of your mean. So that is um, negative 1.5. So we're going to find the area to the left. So meaning, so if this is your, let's say this is your 1.5. So we're going to find the value, the area of this. Okay. And the area that correspond to your negative, to your say value of negative 1.5 is equal to 0.322. Again, how do we get this? Because of the Z table. And therefore, the required area is equal to 0.5 minus 0.4332 4332, which is equal to 0.0668. Therefore, the proportion of the area to the left of Z is equal to negative 1.5 is 0.60668 or 6.68%. So meaning this shaded region is equal to 6.68%. Example number 2 for our case number 2. We're going to find the area below Z is equal to 1.5. So in our chart, it says below, which is also similar to the left, not greater than, no more than, at most less than. And then the Z value is positive, wherein we're going to add 0.5 to the corresponds area. So this will be our operation later. So again, we're going to draw a normal curve. This is your normal curve, 0.5. And let's say this is our z value, that's 1.5. It says below. Okay. So this will be your shaded region. And the area that correspond to z is equal to 1.5 is 0.4332. So the required area is equal to 0.5. Why? Because remember, this will be our operation plus 0.4332, which will give us an answer of 0.9332 or 93.32%. So in probability notification, it says that probability of Z that is less than 1.5 is equal to 0.9332. Therefore, the proportion of the area below of say that is equal to 1.5 is 0.9332 or 93.32%. For our case number 3, models when the required R is between Z sub 1 and Z sub 2. So we have an example. Let's find the area between Z is equal to -2 and Z is equal to -1.5. So again, we're going to draw the normal curve. So this will be your normal curve, your mean. This will be the value of -1, and this will be the value of -1.5 and -2. So we're going to find the area between -2 and -1.5. So to find it, the area that corresponds to -2 using our Z table is 0.4772. And the area that corresponds to -1.5 using again our Z table is 0.4332. So here, it suggests subtraction. So we're going to subtract um, 0.4772 minus 0.332. This is the value of this is the area of your say -2, and this is the area of your say -1.5, which will give us an answer of 0.0440. Therefore, in probability notation, so probability of say that is greater than -2, which is less than -1.5, is equal to 0.440, 0.0440, or 4.40%. So your conclusion will be the required area between Z -2 and Z -1.5 is 0.440, 0.0440, or 4.40%. So this shaded region is 4.40%. I want you to try case number 4.
We learned about computing probabilities under the normal curve. We also learned about the proper use of the z-table. So in our fifth lesson, we will going to learn how to determine percentiles and locate them under the normal curve. So for our objectives, first is to find z-scores when probabilities are given, and lastly, locate percentiles under the normal curve. What is percentile? Percentile is a measure of relative standing. It is a descriptive measure of the relationship of a measurement to the rest of the data. Example, in a test in algebra, you got a score of 82 and you want to know how fared in comparison with your classmates. If your teacher tells you that you scored at the 90th percentile, it means that 90% of the grades were lower than yours and 10% were higher. So there are important things to remember when we are given probabilities and we want to know their corresponding z value. So first, a probability value corresponds to an area under the normal curve. Second, in the table of areas under the normal curve, the numbers in the extreme left and across at the top are z-scores, which are the distance along the horizontal scale. The number in the body of the table are areas of probabilities. Lastly, the z-scores to the left of the mean are negative values. If the exact area is not available, we can take the nearest area. So we have three examples to understand finding percentile better.
Example number 1, let's find the 95th percentile of a normal curve. So, by definition of 95th percentile, this means located in an area before or below the point. We want to know what the z value is at this point. So, this will be our steps in locating the 95th percentile of a normal curve. So, first step, we're going to draw the appropriate normal curve. So, for example, this is your normal curve. Okay. So for our next step, express the given percentage as probability. So 95% is also equal to 0.9500. Step number 3, we're going to split 0.9500 into 0.5000 and 0.45,000. So 0.95. Why did we split it? Because we remember 50% is below the mean and 50% is above the mean. So step number 4, shade 50% of the sketch of the normal curve in step 1. So we're going to shade this part. Remember, by analysis, it says locating an area before or below the point. So here, we're going to shade this part. This is your 50% below the mean. Okay? So step number 5, refer to the table of areas under the normal curve. We're going to locate the area of 0.4500 in the body of the table. So if we look here in the say table, we cannot find the exact value of 0.4500. So we're going to find where 0.4500 is nearest. So here, for this both areas, that is 0 point shade the 50% region. below the mean. So in step 5, we have 0.4495 and 0.4505, which is nearest to 0.4500. So for our step 6, find the say score that correspond to 0.4500 on the leftmost column. So find say by interpolation. So the value of your 0.4495 is equal to, say, 1.64. But why 1.64? So here we have 1.6, and in this column we have 0.04. Adding this both, that will give us 1.64. And the value of your 0.4505 is equal to, say, 1.65. So 1.6 and then 0.05. So let's find the average of your two z values. So this will be your next step. 1.65 plus 1.64 divide by 2. So this is how you find the average of your two z values. That will give us an answer of 1.645. So the 95th percentile is equal to 1.645. So let's draw a line to the normal curve. So let's say this is your 1.645. And then we're going to shade this region. Okay? So your conclusion will be the 95th percentile of a normal curve is 0 is z 1.645. So this will be the 95th percentile of your normal curve, this shaded region.
Example number 2. Find the upper 10% of the normal curve. So, step number 1, we're going to draw the appropriate normal curve. Okay? So, this is your mean. So, for the second step, express the given percentage as a probability. So, 10% is the same as 0.1000. So, number 3, with respect to the mean, locate the upper 10%. So, the word upper meanings, it means to the right of the mean. So, the upper 10%, we're going to locate it here, okay? So, for step number 4, using the upper side of the mean, find the remaining area. So, we're going to subtract 0.5000 minus 0.1000, which will give us an answer of 0.4000. Okay, so for our step 5, refer to the table of areas under the normal curve. We're going to locate 0.4000. So, if you observe, this area is not found in the body of the table. So, we take which is the closest. That is 0. Here, 0.3997, which means its z-score is equal to 1.28. Okay, so z-score is equal to 1.28. So therefore, the upper 10% is above is 1.28. Okay? So we're going to shade the region to the right of 1.28. So here it is. So therefore, the shaded region is the upper 10% of your normal curve. Example number 3. The results of a nationwide aptitude test in mathematics are normally distributed with mean 80 and standard deviation of 15. What is the percentile of a score of 84? So here, since we are interested in the percentile rank of 84, this means finding the percentage of scores below 84. To find the required area for the table of areas, we transform 84 to the score form and then perform the appropriate mathematical operation. So remember on our past lessons on how do we find Z scores? So we use this formula. Z is equal to x minus your mean over your standard deviation. And here in the given problem, our random variable will be 84 minus your mean, which is 80, over your standard deviation of 15, which will give us an answer of 4 over 15, which is also approximately equal to 0.27. Okay, so we're going to locate 0.27 on our Z table. So here, 0.2 and then 0.07, which will give us an area of 0. So 0.027 corresponds to an area to the area of 0.1064. Okay, so now we're going to draw the appropriate normal curve. Okay, so our mean is 80, right? And our standard deviation is 15. So 95. Here we have 65, and so on and so forth. So we're going to locate 84. So this is somewhere located here, right? So this is your 84. Let's draw a line. Okay? So um the required region is below 0.27. Okay? So, let's examine the shaded region. So, therefore, this will be your shaded region. This is the 84% and here. Okay? So, first, let's get the total area below your below z is equal to 0.27. So, to answer that, we have 0.5000 plus 0.1064. Okay? Which will give us an answer of 0.66064. So, converting this into percentage, that will give us an answer of 60.64%. So, therefore, your shaded region, which is this one, is 60.64%. So, the percentile rank of the score 84 in a test is 60.64. So notice that there is no prescriptive procedure in the computation of the say scores and the probabilities. So you really have to analyze the problem carefully and apply what you've learned about the concepts and procedures involving the normal curve. So I would say that first you should determine the givens, and then let's see if there is any formula needed for that, and then you solve that required operation, and then let's find the say scores and so on and so forth. So for our last lesson, we're going to discuss the application of the normal curve.